of this test, you will be asked 12 multiple choice questions. The order may not be the same as this review, however, all these questions will be on the test. Let's start with the first question, multiplying or dividing. Now, when we multiply and divide, we need to make sure that we factor everything as much as possible. So let's start there. C squared, I can write as C times C. C minus 1 does not factor. Times. Over here are numerator factors, so we're going to go ahead and factor that top. C squared is C times C. 5 is 5 times 1. Now to get a total of -6, we need to have a -5 and a -1. Now in our denominator, here, C squared is C times C, and then we have a minus 2C. We saw that we can take out this common factor, we write it once, and then we write the leftover, which is C minus 2. Once I have everything factored as much as possible, we use our multiplication rule that says we combine everything on the top. It is multiplication, and we combine everything on the bottom using multiplication. Once I do this, we can now cancel or divide out what common factors there are. So first thing I notice is I have a C, I have two C's on the top, but I only have one on the bottom, so that's the only one that's going to cancel. We can only cancel one of them. Then I have a C minus 1 on the top and a C minus 1 on the bottom, canceled. What remains is our final answer. We have a C minus 5, and then on the denominator, a C minus 2. It is possible that this would be also multiplied out. C times C is a C squared. C times -5 is a -5C. However, most of the time, our solutions look like this with the factored form. Now, for division, we have to use something or remember something called keep, change, and flip. What's nice about this question is it's already factored for me, so I don't have to worry about trying to factor it. I do need to use the rule keep, change, flip. Keep, meaning we leave that first fraction the way it is. Change, we change the middle sign from division to multiplication. And flip means we completely invert this guy. So x minus 15 on the top with the x plus 4. And on the bottom, x plus 4 and an x plus 7. Now we're going to go ahead and combine them. It's a multiplication, so just like we did on the first question, all our numerators get combined using multiplication, and we don't want to FOIL this out or distribute because we want to keep it as factored as much as possible so that we can cancel things. We also combine our denominator, so let's combine all of that. And then once I have everything combined, we can start to cancel. X plus 4, I have 1x plus 4 on the top with 1x plus 4 on the bottom. 1x minus 15 on the bottom and 1x minus 15 on the top. What remains is my solution. X plus 4 over x plus 7. Nothing else can cancel out because there's nothing left to factor. So that's my final solution. The next two questions are adding and subtracting. And we want to simplify these as much as possible. So it's best to factor everything first to see if we can get a common denominator. Now, when we get a common denominator, remember it's called the least common denominator, okay? So let's look at our factoring first and then see if we can get a common denominator. So on the top here, we're going to factor both the top, the numerator, and the denominator. And then over here, this doesn't factor at all. It's as simple as can be. So we're going to factor this. M squared is M times M. 16 is 8 times 2. I want to combine these to make a negative 10. So that means I'm going to use a negative 8 minus 2. Bottom. M squared is M times M. 40. Factors of 40, I'm going to use 8 and 5 because 8 times 5 is 40. Also, we need a negative 13, and I know that negative 8 minus 5 is negative 13. And I stop and I smile at myself because I see that I can simplify this rational right here. I have an m minus 8 and another m minus 8. One on top cancels one on bottom. So now that it's simplified, I'm going to rewrite this and you're going to see why it made me smile. And the reason is we have the same denominator. Once I simplified this, I don't even need to worry about getting a common denominator because the denominators are already the same, which means we can go ahead and add them. So I write m. So I go ahead and write m minus 2 plus 6, and then we write our common denominator only one time. It's just like when we take out common factors, we only write it once. Same thing with our common denominator. I combine my like terms, so negative 2 plus 6 is 4. So I'm going to have m with a positive 4 over m minus 5. And that is the final solution to the addition of these two rationals. Number 4 is subtraction, but it follows the same rule. We need to make sure we can get a common denominator first and then simplify as much as possible. So let's go ahead and do that. In order to do that, we want to factor. So to factor this first rational, x squared is x times x. 24. Okay, 24 is 12 and 2, but that's not going to give me 5. All right, 24 is also 4 times 6, but that's not going to give me a 5. 24 is also 8 times 3. I can definitely get a 5 from 8 and 3. If I use a positive 8 minus 3, we get a 5. Now let's factor our denominator. For our denominator, x squared is x times x. 21 is 7 times 3. And we need this to add up to a negative 10. So negative 7 and negative 3. Again, I smile because I see that I have something in common on the top and bottom. This x minus 3 can let me simplify this and it makes it so nice because I have x plus 8 over x minus 7 minus 9 over x minus 7. And this makes me really happy because now my denominators are the same. I don't have to worry about trying to find a common denominator because everything canceled. I just need to be careful because this is subtraction, not addition. So when I write my x plus 8, I'm going to do minus 9 over, and then our common denominator, we just write it once. Combine our like terms. 8 minus 9 is negative 1. And there's my final solution to this subtraction. Number 5, we want to find the domain. And I like to remember domain of rationals, domain, and denominator. They both begin with D. And the reason denominator is so important for our domain is because we can never divide by 0. It can't be done. It cannot, there's no such thing as dividing by 0. So for that reason, we always check our denominator to make sure that it does not equal 0. So to do that, we take our denominator, we write that it cannot be equal to 0, and then we solve it. So there's a couple ways to solve this quadratic. You can use a graphing calculator to graph it. You can use the quadratic formula. I, for one, like to factor it because most of these are factorable. This one does factor very nicely. X squared is x times x. 5 is 5 times 1. Now we need a positive 4, so I'm going to use a positive 5 minus 1. Now be careful because this is really tricky. Some people get to this point and then they try to pick the answer just by looking at this. But I promise you, if you write this next step and solve it all the way down to where you're supposed to solve it, you won't make the mistake of picking the wrong answer choice because of negatives. When we solve x plus 5 not equal to 0, we subtract 5 from both sides, and our solution becomes x cannot be negative 5. Over here, opposite of a negative 1 is a plus 1, and we get x cannot be equal to 1. So when I write my domain, we write the set of all x's such that x cannot be equal to negative 5 and 1. And this is the formal way of writing that domain. For number 6, 7, and 8, we're going to use the same function for all three, which is nice because that means we only have to factor it once. So I'm going to go ahead and factor it, and then we will define what each one of these questions is asking. So let's factor this. If I'm going to factor it, I'm going to write f of x equals our numerator factors and our denominator factors. Let's start with our numerator. X squared is x times x. 8, I'm going to use 8 times 1. Because the middle is negative 7, I know that negative 8 plus 1 will give me that negative 7. Now our denominator, x squared is x times x. 2 is 2 times 1. Now our middle here is a negative 1, so that means my 2 needs to be negative and my 1 needs to be positive. And I get really excited again because I can cancel, but we have to wait because we need to answer the question, what the question is asking us first, right? So let's go through each one of these questions and I'm going to define them. First of all, the vertical asymptote or asymptotes has to do with our denominator. We end up solving our denominator, okay? Now, horizontal asymptotes is another story. Horizontal asymptote or asymptotes, we have to do that comparison. So remember in our notes, let's go back there to rationals. We're going to go to more on the graphs where we talked about our discontinuities. And here is our solution tree or roadmap, whatever you want to call it, for finding our horizontal asymptote. And we're going to go ahead and copy and paste this right into our review. Out here on the side or actually let's put it right here. We'll put it right here with our problem for number 7. Just as a reminder of how to find those asymptotes, okay? And then the last one asks for the holes. Remember I gave you another word that also meant hole, and it's a removable discontinuity. So what a hole means is that we can actually find the hole based off of what is being canceled or removed from the equation. So with all of that being said, now let's answer each part. Let's start with our vertical asymptote. Well, let's go back to our factored form here. First of all, we got excited because we saw that this can simplify, right? We have the same on the top and bottom. But remember, when we simplify this, this x plus 1 becomes my whole, where our whole on the graph is. So that's gone, right? Done. And I wrote it here and made myself the note that x plus 1 doesn't completely go away. It's just a whole, right? It has an actual name. Let's go to our vertical asymptote then. Our vertical asymptote is our denominator. Well, in our denominator, we already took the x plus 1 out. So we go to that piece that's left over, the x minus 2. This tells me my vertical asymptote. We solve it, very basic equation to solve. We just move the 2 over and we get x equals 2. Very simple vertical asymptote, x equals 2. Now we go to our horizontal asymptote, and we're going to use this rule here. So when we're discussing the degree has to do with our highest exponents. So the degree of the top is going to be the term that has the largest exponent, and the degree on the bottom, we're going to use the term that has the largest exponent. So in our case, the degree of the top is a squared because that's our biggest exponent. The degree on the bottom is also a squared. And if I compare these two numbers, we get equal. So let's read this guy, because this guy says if the degrees are equal, we use the leading coefficients. So the leading coefficient of the top is a 1. The leading coefficient of the bottom is also a 1. And 1 divided by 1 is 1. Now we calculated the whole at the very beginning. Well, we found it, right, when we canceled out this x plus 1. So for the whole here, all I have to do is subtract 1, and it tells me there's a big fat hole at x equals -1. And there it is, all three of those answered based off of just factoring. Now we're going to actually solve some equations, and we're going to also check the solutions to make sure they are not extraneous. Remember, because our solution has to exist in the domain. So for number 9, we're going to go ahead and we have to find that least common denominator. So I'm going to start by factoring this guy here. I love to factor these. It's got a minus and a perfect square, which means that this is the square root of 25 is 5, so a plus 5 and a minus 5. It works out so nice because I have an a plus 5 and an a plus 5. So when I'm writing down my least common denominator, a plus 5 is the first factor. Remember, we only write it once because they already have something in common. Then I look and see my second factor here is a minus 5. Also, they have it in common. So I only have to write it once. Once we identify the least common denominator, we multiply the whole equation by that denominator. So a plus 5, a minus 5. And when we say multiply, we literally mean multiply all the numerators by this guy here. So I have a, my common denominator. I have a plus 2, my common denominator. Then I have an equals 6, my common denominator. Sorry, my pen went a little crazy there. And then our denominators, this one, since we already factored it, I'm going to go ahead and write it in that factored form because we are trying to cancel out those denominators. The second denominator here was an a minus 5, and this one had an a plus 5. Our favorite part of solving these is we get to cancel, 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 cancel. We're left with a plus. Cancel, cancel, we have a 2 and an a plus 5 equals cancel, cancel, a 6 and an a minus 5. Now this looks like an easy Algebra 1 equation to solve, and really if you don't think it's that easy, that's okay. I'm going to show you how to solve this step by step. We start by distributing in that 2. So I have an a, 2 times a is a 2a, 2 times 5 is a 10. Same thing here, multiply in, distribute that 6. 6 times a is 6a, 6 times negative 5 is negative 30. We're going to combine our like terms over here. That gives us 1a plus 2a is 3a, and then we have a 6a minus 30. When we're solving and we have variables on both sides, we need to make sure all our variables go on one side of our equation. So we are going to go ahead and subtract this 3a, get it to that other side, and we get 10 equals 6 minus 3a's is going to give me 3a minus 30. Finally, we're going to move that 30 over. The opposite of a minus 30 is a plus 30. And 10 plus 30 is 40. Our final solution here, we divide by 3 and we get 40 over 3. Now we can use our calculator to check our solution, which I'm going to do real quick here. And the way we're going to check this is I'm going to put my whole left side. So on the left side of my equation here, I'm going to use x instead of a because we are graphing. So x squared minus 25, and then I have a plus 2 over x minus 5. That's my left side, and now let's do the right side. We have a 6 over x plus 5. Now these two graphs do meet, and it even shows me the dot here. It's at 13.333. Well, our answer was 40 over 3, so let's see if that matches. 13.333, let's check it out, 13.333. They match up, so that is my correct solution. So your graph can help you find and make sure that you are solving things correctly. Let's look at number 10. Number 10, to solve this by hand, we're going to do something very simple. We're going to do cross multiplying. So I'm just going to multiply across like so, and I'm going to write negative 4 times x minus 5 equals, and then a 5 times x minus 2. Now I can do this because I don't have anything being added over here or added out here on this side, so it makes solving this equation so much more easier. Because now I just need to distribute. I don't even need to worry about what the common denominator was, because I already cross multiplied. This gives me negative 4x plus 20. This gives me 5x minus 10. And we need all our x's on one side, so plus 4x to both sides. And we get 20 equals 5x plus 4x is 9x minus 10. Let's get rid of our 10. The opposite of a negative 10 is a plus 10. So we get 30 equals 9x. Divide by 9. And I believe that reduces beautifully to 10/3. You don't have to reduce it if you don't want to right here, because we're going to check it on our calculator anyway. So let's check this on our calculator. Again, we're going to do the same thing. And actually, I'm going to go ahead and write in my solution, which was, what did we get? I already forgot. 30 over 9 or 10/3. So that means my answer is going to be a decimal, right? Let's type in our equation. On the left side, we had -4 over x minus 2. On the right side, we had 5 over x minus 5. And I'm going to zoom the, oh, right here, I can see they meet. And look where they meet, 3.333. Exactly what I found with my solution. So I know my solution is correct. For the final couple questions, we have graphs of exponentials. So this question 11, on your test, it's kind of going to be opposite. I'm going to give you a picture of a graph, and then you're going to have to match it to the correct equation. So I am going to review just how you type this in, because obviously all you have to do is type it in your calculator and find the graph that matches the graph that's given to you. So we're going to type this in with our little exponent, and there is our picture of our graph. That's it. For the last question, it's a transformation, and I love this type of question because it's not asking us to graph the transformation. It's only asking us to describe that transformation. So I'm going to highlight each part that we learned about. We learned about what happens when this got a minus. We learned about what happens when we have stuff in the exponent. And we learned about this out here at the end. So let's isolate each part. Why? The one that's most obvious that I always remember is this guy. This is the easiest one. Because it's negative, we move down, right? The next obvious one is in the front, the negative. What the negative is going to do, it's going to flip it or reflect, but we need to know which axis. So when we talk about flipping it, remember we actually flipped it this direction, which is across the x-axis. So when we reflect, we are reflecting across the x-axis. And the last piece right here, remember when it's in the exponent, we think about like the opposite. So instead of moving to the right 3, we're going to move to the left 3. Because if you remember in our notes, this was a minus h, which means opposite. So this plus 3 actually means left 3. So make sure you are looking for those keywords, and you will always get these transformation questions correct. That's the whole review. That's every single question that's going to be on your test. Good luck, and I will see you next week.